Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about type inference. So guys, if you are working on generics, then this concept is a very crucial concept to know, that how Java compiler automatically determines the type of parameterized type, aka generic classes or generic methods. So if you are willing to learn how all of this happens, then this video is for you. So make sure to watch this video till the end. So without wasting any time, let's get started. Alright guys, let's begin this video. So the first thing we need to understand is that what is meant by type inference. Well, type inference is a Java compiler's ability to look at each method invocation and corresponding declaration to determine the type argument that make the invocation applicable. So this is the definition of type inference. If this sounds confusing to you, don't worry. I am going to use a very simple example to understand this concept. So in front of you, you can see that there is a main class, and inside of this main class we have main method, right? And here you will see that we have one method pick, okay? And this is a generic method. The type parameter is t, the return type of this pick is t, and this pick method is accepting two instances of type t, right? And then it is returning a2. Now let's call pick by passing d as argument and a new instance of ArrayList of string as argument. And we are storing the return type of this pick method into a variable of type serializable. Now this is the entire code. Now as I said that type inference is a Java compiler's ability to look at each method invocation and corresponding declaration to determine the type of argument, right? So we can say that this is the method invocation, right? And this is the method declaration. Now if I ask you that how Java compiler is going to determine that what is the type of this type arguments, then what would be your answer? So let me show you how compiler will determine the type of t. So here how it happens, that compiler will check the type of d, and the type of d is a string, right? Because it is a string. And now here the type of ArrayList is ArrayList, right? So the first argument to this method is a string, and the second argument to this function is ArrayList. So if you look at both the classes, you will see that there is one common thing between these two classes, and that is both the classes implement serializable interface. String is also implementing serializable interface, and ArrayList is also implementing, let's go up a little bit. You can see that ArrayList is also implementing serializable interface. So this is where Java compiler comes to know that serializable is the common type between string and ArrayList. So in this case, Java compiler will assume that the type of parameterized type t is nothing but the serializable. So which means the instance A is of type serializable, instance A2 is also a type of serializable. Now what does it mean? So it means Java compiler always finds the most specific type that works with all the arguments, right? So you can see here that this argument is also of type serializable and this argument is also of type serializable, because both the classes implement serializable interface. And that is why we are able to store the return type of this pick method into a variable of type serializable. So this is how type inference works. So here Java compiler is inferring the type by looking at the most common specific type of both the arguments and then decide that what is the type of t. So the process of determining the type of type arguments by a compiler is called type inference, and this is the most important topic in generics. Why? Because generic entirely works on type inference. So now I will show you multiple examples so that we can understand all the nuances of type inference and how type inference works. Now let's create an instance of box, box, give it a name, and new box. Okay. Now let's go to this box class. So if you go to box class, then you can see that we have a box class, and this class is generic class. This class is one property value of type u. It has two methods, one is set and one is get. Set method is used to set the value and the get method is used to get the value. Okay, so far so clear. So here I am invoking the constructor of box class to create an instance of box, okay, and then I am setting the value of box. So let's call box.setValue, and I am passing here integer.value of and give it a 1, okay. Now let's call integer I is equal to box.get method, okay. Now if I ask you that what is the type of object we can expect from this get method, then what would be your answer? So if you remember from the previous video, this invocation is nothing but we are using a raw type, right? Because the box class is a generic class and we are not giving any type argument and we are not passing any type argument, which means we are using a raw version of this generic class. And what happens in raw version? It simply gets an object of type object. You can see here that the provided is object. So in this case, we have to convert this object into integer explicitly. This is how it's going to work. Okay, so far so clear. Now using this example, we are going to understand two very important concepts, that is target types and the type witness. Let me show you. So if I don't want to cast the return type of this method into integer, then what would I do? It's simple. We just have to pass the type argument, as simple as that. And how we do it? We simply use arrow brackets like this. So here we have to pass type of type argument. So let's pass integer. And here also let's pass integer. So now, as the box class is generic class, the compiler will understand that the type of u is nothing but it's an integer. Okay, so it's gonna set integer value into this attribute and it's gonna return an integer value. Now if you check the return type of this get method, you will see that we are getting a value of type integer and we do not need to convert that type explicitly into integer. So this is the first way of telling the compiler that we are going to store an object of type integer, and so that we are also expecting an object of type integer. So far so clear. Now here, as I said, that we are gonna study two important concepts, that is target types and the type witness. Now if you look at this statement here, we are invoking the constructor of box class to create an instance of box, right? And here we are passing type argument two times. One is here and one is here. So what do you think? Is it okay to pass type arguments two times redundantly? Is it of no use, right? We can also pass type argument only once, okay? The first type argument we are passing here is called the target type, okay? This type argument is called target type, and this type argument which we are passing at the time of creating an object, we call it type witness, okay? So this integer is target type and this integer is type witness, okay? Now moving on. So in Java 8 or later, we can completely omit this type witness from here, but still you will see that the Java compiler is still automatically inferring the type of type u. How is it so? Because here Java compiler is inferring the type of t from the target type. And what is the target type of this instance? It's a box of type integer, which means the type of type argument u is nothing but integer. That is why it is not throwing an error. We are still able to store the value, return value of get method into integer variable without explicitly converting it into integer. So we have two options. So using these two options, Java compiler automatically determine the type arguments using the target types and using the type witness, okay? But type witness is optional. If we have target type, then we can simply omit the type witness and it will work absolutely fine. So now I hope that you have good understanding of what is type inference, what is target types, and what is type witness. So now let me show you one more example to understand type inference a little bit better. So let's remove this piece of code. So let's see this example, okay? So I already showed you the box class. It's a generic class. It has one value and we have two methods to set and get this value, okay? Now let's see this class box demo. So this box demo class has one method to add boxes into this list, okay? And this method is also a generic method. And what is the type parameter here? It's u, okay? So this method is getting a u, and this method is also getting a list of box of type u. So what are we doing here? We are creating an instance of box first. Here you can see that the type witness is, we are just simply using a diamond notation, and then here we are defining the target type, okay? And then we are setting this value into box object. Then we are adding box into this boxes list, okay? Then here below we have one method. This method takes a list of box of type U, and it is simply printing the content of all the boxes on the screen along with the counter, okay? This is a simple basic program, okay? So this method is used to add the boxes, and this method is used to print all the boxes on the screen. As simple as that. And both the methods are generic method of type U. Now let's go to main.java class, okay? Now here you can see that I am creating a new instance of array list, okay? And what is the type of this array list? It's of type box of integer, okay? Now in this second line, I am adding a box into list of boxes, and this box is of type integer. But if you look at the subsequent statement, you will see that I am not passing a type witness to this method, but still it is working. Let me show you. Let's run the program, and we have three boxes here. Box 0 contains 10. You can see here we are passing 10 here. Then we have one box with value 10, and then we have box 2 with value 30. So how is it working? We are removing the type witness from here. Still Java compiler is able to infer the type of type arguments, that is U. How is it possible, and how it is working internally? Even if I comment this piece of code and run the program, it will work absolutely fine. So the question over here is, how is it working? So well, here Java compiler infers the value of type argument from the method argument. So you can see over here we are calling addBox method 2 times, and the value that we have passed into this method is of type integer. So by looking at the method argument, Java infers the type of U as integer, and this is how it is working internally. So Java compiler uses target types, type witness, method arguments to infer the type of the type arguments. As simple as that. Okay, now let's see the next example to understand type inference little bit more. Alright, so let's see this example. Here we have a class, my class, and this class is a generic class, and the type parameter of this class is X. Now inside of this class we have one constructor of this class, and this constructor is also a generic constructor, and the type parameter of this constructor is T. So you can see that X and T both are different type parameters, okay? This X is for class, and this type T is for constructor only. Okay, now let's move on to main.java class. Now here I am creating an instance of my class by invoking the constructor of this class, okay? And here I'm using the type witness. Mind you, I am using a type witness here, okay? And I am passing an empty string into the constructor of this class. Now if I ask you that what is the type of this X and what is the type of T, then what would be your answer? How Java compiler is going to infer the type of T and X here? So let's see it. So as we are passing type witness into the type argument of this class, which means the type of X is integer. As simple as that. So here compiler will use the type witness to determine the type of this X. Okay. Now what is the type of this T? So as you can see that we are passing a string into this constructor, which means compiler will infer the value of type T from this argument, and the type of this argument is string, which means the type of T is string. Okay, so far so clear. Now let's replace this piece of code with this piece of code. So here I am creating a new instance of my class by invoking a constructor and passing the argument as blank string, and then I am storing the object into a variable of type my class of integer. And you can observe over here is that I have completely omitted the type witness from here. Now tell me that how compiler is going to determine the type of this X and T. So here in this case compiler is going to use the target types and the argument of the constructor. So this time the target type is what? It is integer. As I explained before that this is a target type. So let me explain you what is target type. So whenever we are expecting something, or any method is expecting a type of argument, and here you can see that we are expecting an instance of my class of type integer. So whenever we are expecting something of some type, then we call it target types. So this is how you can understand what is target type. Okay, so here as we are expecting my class of integer type, which means Java will infer the value of type X as integer. As simple as that. And what about the type T? As same as before, that we are passing an argument of type string. That is why the type of T is going to be string. As simple as that. Okay, so I hope everything is clear so far. Now let me show you the next example. Alright, let's see this example. So here we are calling collections.emptyList method, okay, and we are storing the return value into a variable of type list of string. So now let's go to collections.emptyList method. So if you see collections.emptyList method, this method is a generic method, okay, and this method is returning a list of type T. Now in this case, can you please tell me that what is the type of this T and how Java compiler infers the type of T? It's pretty simple. So let's see this statement carefully. In this statement, what is the target type? Target type is list of string, and this is returning a list of type T. So here we have list of type string and here we have list of type T, which means compiler will infer that the type of T is string because the target type is string, right? As simple as that. Now let me take this challenge a little bit further. So let's see this example. So we have one method process string list, and this method is accepting a variable string list of type list of string, okay, and here we are invoking this method by passing collections.emptyList. Now can you tell me that what is the type of this collection.emptyList and how Java compiler is going to infer the type of return type of this empty list? So again, it's going to check that this method is a generic method and it is returning a list of type T. And what is the target type here? Tell me quickly. Here, as it is a method, the target type is nothing but the type of the argument of this method. So what is the target type here? List of string, list of string. So which means that the type of T is nothing but string. So here also compiler is checking the target type. In context to method, the target type is the type of argument. As simple as that. Okay. So I hope this is clear to you. Now let's move on to the next example. Alright, let's see this example. So here we have two overloading methods. Okay. This invoke method is taking an instance of runnable and this invoke method is taking an instance of callable, right? So let's go to runnable and callable and let's see what it is. So let's go to runnable and you can see that so runnable is nothing but it's an interface with only one method defined inside of it. Okay. Similarly, let's go to callable interface. Let's go to callable. Here you can see that callable is also an interface and it also has one method, okay, defined inside of it. But this method returns a value of type V. Okay. So both the interfaces are functional interface, which means we can invoke this method by passing a lambda expression into it. Now guys, if I ask you that how Java compiler is going to decide which method to call, what would be the criteria? Now how Java compiler determines that what is the type of this lambda expression? So first of all, we have to be clear that both the interfaces are functional interface. So which means we can pass lambda expression. Okay, this is clear. This is we are sure about. Okay. Now the question over here is how Java compiler is going to decide which method to call. So here Java compiler is going to use two Java language features. That is, one is the method overloading resolution and second one is the type argument inference. So guys, if you look at both the interfaces, you will see that the runnable interface has one method, but it doesn't return anything. It is simply returning a void. And if you look at the callable interface, it has one method, but it is returning a value of V. And if you look at this Java lambda expression, the Java lambda expression is also returning a value of done. And that is why we are storing the value in a variable of type string. So which means Java compiler infers that the lambda expression is returning a value and the callable interface also has method that is returning a value. So which means the type of this lambda expression is nothing but it's a callable interface. So this is how Java compiler is going to invoke this method instead of this method. So let me show you. Let's print this string on the screen. Let's run the program and you will see that done is printed on the screen. And how is it so? Because in both the methods, so the method with the argument of type callable is being called by Java runtime. And the next question is, what is the type of this T? It's simple. The Java lambda expression is returning a string. So which means the type of T is a string. As simple as that. So this is how Java compiler infers the type of type argument using target types and the method arguments. As simple as that. So guys, I hope now you have a good and strong understanding of what is type inference, how it works, and how Java compiler automatically determines or infer the type of type argument and choose most specific type that works with all of the arguments. So this is all from my side for this video. If you learned something valuable from this video, then hit the like button in order to make YouTube algorithm happy. Please subscribe to the channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. Thanks for watching. See you in the next one.